Hello, Professor Colby Davy. I'm going to be showing you a halogenation electrophilic aromatic substitution. So here, in this situation, we are substituting a proton with a halogen. Our halogen today is chlorine. This mechanism would be similar, if not pretty much the exact same for any other halogens. Okay, so the first thing we're going to do is a little bit of a pre-step here, actually. Sorry, I'm trying to keep the lighting right. Pre-step, we're going to draw out these guys here. We have Al, Cl, 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 and Cl, Cl. We're going to draw out all the lone pairs because why not? All right. Okay, so because this aluminum is attached to all these chlorines, it has a delta plus, so that means it's looking for, we can look for more electrons. So we're going to do, this chlorine is going to share with this aluminum, and this is going to create aluminum, Cl, chlorine, 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 chlorine. Notice we have all these lone pairs still. This is no longer a delta plus, it has now become negative, and here, since it has these two bonds, this chlorine becomes a positive. Yeah, so next, we're gonna actually do the real halogenation. Now that we got that out of the way, let's draw out what we start with here. So, go. Alright, and then we're gonna put, well, I'm not gonna redraw that actually. Okay, so this is what we're starting with here, and if we're trying to replace this hydrogen with a chlorine, we gotta get rid of this double bond. So we're gonna give it to this chlorine. And sort of in a chain reaction, that means these shared electrons get brought to this chlorine. And that's good because that's going to make this chlorine happy, and this chlorine is going to come down and join this carbon. So it's going to look like this. So we're going to still have this hydrogen, but in doing so, it's going to cause this carbon to be positive. So now let's look at what we have now. So now let's look at what we have now with our aluminum. Still negatively charged. These chlorines have all their lone pairs. So what we're going to do here is give these shared electrons to this hydrogen, and then that's going to bump the electrons here, getting rid of this plus. Therefore, the end result here is exactly what we were looking for. Cl goes here, no positives. Notice that double bond is back because of this here. And we got this little group hanging off. And we end up with what we started with, actually, funny enough. Chlorine, aluminum, chlorine, chlorine. And this H and an extra Cl. And that's what we end up with.